recording. Share screen. Share. Okay. Okay. Let's hope we can get done with this lecture soonish. Can I get a confirmation from the Zoom people that you can still hear us or hear me?
Yes, we can.
Okay. Okay, so 1, 2, cool. I was talking about complexity of ML workflows. 10 years ago, we were only running on CPU. If you want to run a ChatGPT type model today, you need like a cluster with at least 4 very beefy GPUs today. So I talked already about this bridge between development and operations that we kind of need to scratch. We need further collaboration. So since we're training more and more complex models, like for example, the ML engineers need to talk better to the data engineers to figure out what is the actual data we need to gather to fulfill the requirements of our model. How much data do we need to gather? Like millions or trillions of data points. This is like something that's beginning to be more important. I don't know if you saw in December, EU was the first to like have a EU AI Regulation Act, something, where they basically ban certain AI applications. So anything that has to do with mass surveillance, that seems to be pretty good. So I foresee a future where we will see more and more regulation, and when companies then want to do anything, they essentially need to prove to the regulators that our models are behaving well and are fulfilling some compliance. Like the early example was the GDPR, for example, that you cannot train a model, or you can train it on GDPR, but you need to understand where data came from and all these regulations about that. Optimization, scalability, again, models are just growing in size, data is growing in size. So we want to take care of this as MLOps engineers. Continuous integration, continuous deployment, make sure that everything works, even after a year or 2, or how long we want our machine learning model to actually run in production. Infrastructure orchestration, also a very big growing field. As these workflows become more and more complex and the resources needed to them to run them, we need to be able to control the infrastructure we are running on in a much more complex way than we originally had to do. Cloud services, we have seen a large adoption over the last 10 years. If we look back to the mid-2000s, every decent sized company had their own like mainframe and they had their own IT department. Don't really see that more. Like big companies as Novo Nordisk, they have moved on to fully embrace like cloud services such as Azure and AWS. And it's kind of funny now we are seeing with like the inception of large language models and ChatGPTs that some companies are now going back to mainframe because they are scared that like our data gets leaked somewhere. So they would rather have it in-house, maybe have an open source large language model that can then run on their data, and they control everything. Of course, Azure and AWS and Google is already working on these like private instances of ChatGPT or whatever large language model you work. So maybe they will deal with it. And the business impact. Yes, there's money to gain. So therefore, MLOps is hot. If we look at OpenAI, the golden child of Silicon Valley at the moment, it's kind of funny to see what actually contributed to the success of OpenAI. So there's of course funding. They needed a lot of money, especially for the compute part. I would say the big factor right now why OpenAI is currently winning over all other companies is data. So I was on a summer school in South Africa in like 2018, and some of the participants, local participants, they were talking about already there, OpenAI was basically gathering this human instructed data. So they were asking these people saying, this was generated by machine. What do you like about it? What don't you like about it? Such that they here in like 2022 could do this reinforcement learning procedure where they're trying to align the large language model output with what we want as humans. And of course, they did it in Africa because labor is cheap. People, so there's no, they have a lot of very smart people at OpenAI. Like one of the authors on this AlexNet paper is hired there. He's been one of the great like inventors of the whole GPT lines of model compute, of course. And then the last one, I don't think they talk so much about it, is they have a very, very good service contract with Microsoft. So essentially, when they say, we have a new model, we want to deploy it, Microsoft says, okay, here it's 1,000 workers, let's help you do it. And that's pretty like valuable for a company such as OpenAI. And I think that's really what enabled them to be like the ChatGPT was the service to that's fastest gain like 1 million users or something, even over TikTok and Instagram and so on. And it's clear, just like the last line, that in the same breath that Microsoft gave OpenAI 10 billion, they fired 10,000 workers. So even Microsoft as a cloud provider, as like front runner in some of this large language model, is really banking on that a lot of even their workers' jobs will be automated in the future. So let's see if we all have jobs in a couple of years. Cool. So every year, a company called Gartner, it's like a consultancy firm, they produce these hype cycles. And essentially a hype cycle is just a way to say every technology seems to, when like some new technology happens, MLOps is up here, what usually happens is that a lot of people get on the hype, say, wait, let's get some investments, like these big capital funds, like saying, hey, this seems to be hot, let's invest and invest and invest. And at some point we need reach the peak of inflation. And suddenly people realize, hey, this thing we invested in, maybe not, it's not delivering the actual value that we were thinking. Like we gave these people 100 million or something, and they can produce a revenue of 1 million a year or something. So it's going to take 100 years to get our money back. So a technology, it goes down, and it's like, okay, now we don't want to touch it at all. And some people then keep track and saying, hey, there's still some value in this. It was maybe overhyped, but let's just continue working on it. And at some points, technology usually stables out. And you could see back in 2021, MLOps were here. So it was on its downfall. And I think in today's landscape, we are actually out here. So yeah, what happened before 2021 is a lot of startups happens. A lot of money was invested in MLOps. Then we had its downfall after 2021. And today we are seeing that the open source tools and the MLOps tools that are out there, they're really great. So whoever proved that they could provide a good service over the last couple of years, they are now in a stable state. And all these investments, essentially, if we consider these three factors I talked about that to deliver value, all the money went into technologies. So, and that's what we can that's what I'm going to teach in this course. You will learn about a lot of the tools we use for MLOps, because I actually don't know anything about process and mindset. Cool. So if we look back to 2006, if I wanted to take this fancy figure from hidden technical debt, and I wanted to implement every box in some way, what I would do is that I would sit down and write like Java for like basically everything. I had to reinvent the whole figure from scratch, writing everything myself. And there's of course the pro that I got full control, but to get just to version 1, it's very, very hard. It's hard to maintain, and it requires a lot of manpower. What we have seen over the last couple of days is that MLOps as a field now has a lot of tools, and essentially no matter what you want to do, there's a tool for it. So, for example, today we are gonna talk, or in the exercise, you will be working a lot on versioning and versioning of data and code. And today there exist at least a couple of frameworks for doing exactly this. So the pros of this is that it's much easier to get started today. And it's much easier to iterate because you are getting a lot of functionality for free. But what you will see also in this course is that framework integration can be really hard, and that will be the main struggle point for basically all groups. And it can be really hard to say, okay, do I want, I need some, what do we want to pick out? Let's say I want some processing. Do I want Dexter or Spark, for example? It can be hard to say, should I go with this framework or this framework? That's why in this course, I kind of present like some good options. I'm not saying they're the best, but you at least know something about basically every box after this course. So today, if I had to do the project back from 2006, I would basically just pick a tool for every single thing I wanted to do. So the feature exact manual code I could do in PyTorch now. Hydra for configuration. You can do, there's an exercise on that tomorrow, and so on and so forth. Going back to this technical debt concept I talked about, if you don't pick the right tool for the right job, this is essentially what leads to technical debt. So I write some spaghetti code now instead of choosing like a major framework which can deal a lot of it. And when I went to scale up, I figure out, hey, then I need to write more code instead of choosing a framework that can help me do this much more easily. So I think this is one of the last slides. In some sense, you could say MLOps is a kind of a full stack, at least full stack in a machine learning sense, that we try to deal with everything from data through operations. And if I have to give you like some way of saying, should I go with one framework over the other? I have this called 4 C's. It stands for cost, courage, complexity, and community. So if I say I should I go with framework 1 or should I go with framework 2? First of all, I look at the cost. There must be some requirement. Do I need to keep everything open source because I have no budget, or do I have some budget so maybe I can get some enterprise features? Coverage, that means like I have some specific requirements. Does framework 1 actually fulfill them, or is it framework 2 that actually fulfills them? Complexity, that's like how easy is it to get started? I think we all encountered some software where the documentation really sucks, and that can be really adds up to the complexity of getting started with something. So I would rather have a framework that's not that complex. And the last one is community. Like, can I get help if I'm struggling? And if we're talking like a paid service, that would maybe be some kind of service contracts. So I'm on the last slide. MLOps at its core, I would say, is really about delivering value for business or in research. It's thinking about this whole pipeline and the life cycle, not just like now I'm doing this, and trying to account for the long-term goals from the start. Cool. That ends this weird lecture that was split up. So let me I think I'm still sharing my screen. Let's just quickly talk about today's exercises. So as yesterday, there's 4 modules. The first one is on Git. I hope many of you already know Git. Then you can, of course, skip this module. There's one on code organization, which has seen a lot of changes since last year, so I don't hope there's too many introduced bugs. But this is essentially something about let's try to standardize how we organize our code. There's the first optional module on good coding practices. So feel free to do this if you like, but you can also skip it. And the last one is arguably the hardest one today. on data version control. DVC is a fantastic framework for what to do, but every year I encounter a new bug or a new problem or something. So, and it can even be like the same group that have done things together. It may not work for one person. So, what I'm trying to say, it's not you, it's DVC. But I think try to go through it and see how far you can actually get, because it is a wonderful framework for what it does, which is version control data. Okay, so I'm gonna mute myself now. We have a 5-minute break, so 9:55, and then I promise to try to live code yesterday's final MNIST classifier exercise. Check.
Når nu jeg laver de her, hvor den kalder de her filer igennem makefile, og så kører den så som et main script, altså du kan lave sådan en if name with this main, og så lave det der.
Så ja, det kan du godt. Altså, så skal du bare add til din makefile. Okay, så prøv at kigge lige på makefile. Bare for eksempel. Så jeg vil gerne egentlig ikke så bare sige for eksempel case. Det er helt normalt så den bare siger, at definerer en kommando, som den depender på make requirements, bare for at sørge for, at hvis jeg har lyst til at kalde det, så installerer jeg lige om requirement her, og det er en tilleder, som gør det selvfølgelig området. Så har jeg lavet en variabel op, som basic bare. Så bare læse Python, og så projektnavn, data, og så så det her står egentlig bare Python kaldt en fil. Okay, så den bliver kaldt som en fil. Ja, okay. Tak.
Yeah, regarding the oral exams.
Yeah.
So we have a 3-week course. Are the oral exams within those 3 weeks? So
It's on 9 to.
Oh, okay. So the week after.
I have a question regarding one of the modules. It was the one with the cloud.
Yeah.
It says something about that we need to get a credit.
Yeah.
Are you providing it? Or?
Yes. So I will be providing $50. Do you need it now?
I'm kind of ahead of the schedule.
Okay. Okay. I can provide it tomorrow.
Okay. Okay. Brilliant.
Cool.
Okay. Thanks a lot.
Ja. Så jeg bliver her indtil 2. Jeg kommer lige til at holde en pause mellem 12 og 1. Men Cool. Okay. Okay, so let's get started. Let's see. I prepared a bit, not too much. So I just made a folder here with all the data. I need to share screen. Cool. Okay. So I created a folder and I put in the 3 files and the requirement files. And let's just I need a terminal. Here. Let's open this in Visual Studio Code. Cool. So the task is to take in this data and train a model and hopefully get above 85 accuracy on the test set. So let's just create, and then we need to organize it after. But let me just go through at least the coding part. So let's do just main2. Okay. First, we're gonna import our very favorite. Can you see anything? Maybe. Cool. Okay. So we're gonna start with Torch because that's our main computational engine for what we are gonna do. Let's see. Can't see your screen. Cool. Hopefully you can now. And yeah, we also want some to import the NN package because we want to do neural networks. I'm using Copilot, if that's not clear. Which of course you're also allowed to do that. Okay, the first task is probably to load some data. So let's see. My data is currently organized in a way so I can see it has an extension called PT, and that's like an inside trick. If you don't know, PT is usually used for saving tensors in PyTorch. It's underneath, it's just a simple pickle file, but there's a convention to, if you see a file called PT, it's a PyTorch tensor. So let's see, I want something train data, train labels. I have multiple files, so I probably need a list that I can append to. So I have 5 files, and then I say train data, append, and then I need to use torch.load to load these files, and they are called train images i.pt and train labels append torch load train target pt. So let me just why can I not? I need a terminal. Give me a terminal. Cool. Okay. So of course the very first thing we should have done is create a conda environment or any kind of virtual environment, and I have a lot of stuff in this environment. I can here, if I wanted to create a new one, final exercise, I probably want Python 3.10. I also want some to make sure pip installed. I like to use IPython for some more interactive coding.
We are recording this.
I think so. How can I see it? Yes, it's still recording. Cool. Thanks. iPad. That's probably what I want to start with. Cool. Yeah. Oh, another trick I can mention is, so Conda is kind of a bit loaded, so it comes with a lot of extra software. So a good way to not install this in when you create a new environment is to run it with no default packages, and then you get packages. Then you get like the most bare bone thing. So this list is okay. It's already fairly short. Hopefully it should be like a tiny bit smaller this time. Not really. I think I also cleaned my my default Conda environments at some point. So, so I just want to get to the stage where I can activate it and start installing Torch, because that takes a freaking long time. Cool. Conda activate final exercise. The next thing I need is, of course, Torch in this environment. And because I have a NVIDIA GPU, I know I need to just look up what CUDA version I'm running. And then usually I always go and Google install PyTorch because they tend to change it a bit. So I think I need Windows pip Python, and I need something like this to get the version that fits me. I don't want this. I don't want Torch Vision. I just need pip. So hopefully this. Okay, let's just quickly go back to the coding part. So now hopefully this code should load the training data. Then we also need the test data. So test data, and there we just have one file, and this seems correct to me. And we have test labels, and this also seems correct to me. Yes. And then let's just do train data dot shape labels. Come on. Cool. So let's now, while it's still installing Torch, let's just continue. So assume we have our data now. Now we need to turn it into a data loader. And so for that, we go into the utils data package like that. And what I want for data loader to work, I need to provide it as not tensors, but a data set. And an easy way to convert a tensor to a data set is using the appropriately named tensor data set. Cool. Like that. And let's just see, we want some, I think we can fit something large here. Let's just agree on having them up here, our hyperparameters. So batch size, 6, learning rate, something. And what do we need more? We number of epochs, let's say 20. Okay, so we have our batch size, and this should probably be a train data loader. Then we have test data loader. Data loader. And that's somewhat the same. So we have loaded in our model, we have converted it to a data loader so we can process in batches. Now we need a model. If you looked at the data, I hope you all did that. You will see it kind of reminds of MNIST, but the corruption I've done is I rotated it a bit. And I hope this would make it somewhat harder. But I learned at least this morning that you can still make do with a fully connected network. But it's still images, and images kind of demands that we try to make use of this spatial structure. So let's use a convolutional neural network. So I will define a sequential because I, of course, want to do a deep neural network. So no, I don't want linear layers. I want convolutions, and in particular, I want 2D convolutions. My images have one grayscale channel, and let's just 32 filters. That seems okay with me, and a kernel size of 3. That's also okay me. What I really like to do, because I usually tend to forget what shapes I'm working with, is that I know my input is like some batch size 1, 28, 28. And correctly, we know that we are doing 32 convolutions or filters. So the 1 becomes 32, and the 28 becomes 26 because. Okay, so when you have an image and you have a convolution and you're not doing padding, you can only do convolutions where there is full overlap between the kernel and the image. So that means on the very border pixels, the kernel is like kind of sticking out one because it's a 3x3 kernel, and that means that there is kind of one pixel we are not overlapping. So like the kernel can only work one step in, and that means we are losing 1 pixel in every direction. And that's why it becomes 26, 26. Let's pick some activation function. I think I'm in the mood for leaky ReLU. Leaky ReLU. Then let's do another convolute. Not that. Now we have 32 channels, and yeah, let's just go to 64. That sounds fine. And again, the 32 becomes 64. It's the same deal. We are still running with a kernel size of 3. That means that we are missing some border pixels. So we again, like the spatial dimensions gets reduced a bit. Let's do a new leaky ReLU. Should we do, no, let's do, I don't know, max pooling? Max pool 2D. So max pooling works by averaging 2x2 pixels. And that means that our spatial dimension get halved. Okay, now I think we are ready to flatten this. And that takes essentially, it leaves the batch size alone, but then it takes all the rest dimension and flatten it into one long vector. And correctly, it says now the size is 64 times 12 times 12. After this, we can do a linear layer. We correctly get this, and now it actually got it wrong because we have 10 classes. So this is my model. It's still installing Torch. What I probably want at some point is also to name a device. This seems correct to me, so I'm asking, is CUDA enabled on this particular machine? If it's enabled, define a device named CUDA, else define a device called CPU. And that means after defining my model, I need to make sure it's on device. Why your VS Code can autocomplete the mine. Yeah. So I'm using Copilot. I think Copilot is free for all students with having a GitHub account. And then you go in extensions, and I have this extension called GitHub Copilot, and also this chat function. I don't really use it, but that's probably you could probably ask it in the right way, say, just give me an image classifier, and it will write all of this for you. Okay. Cool. Now we are actually ready to test something. So I really like to use IPython. That is, instead of using what many of you, if you're using notebooks normally, this is kind of the interactive version in a terminal. And it has a special command called run, and that just corresponds to running the script. And we call this main2. So let's just see if it actually runs. Wow. I just want to check if this We can just check device. Ah, I probably forgot to save or something. 2. Cool. So I forgot a comma here. So that's the danger of using Copilot. You trust it too much. I'm still trusting it too much. Yeah. Comma. Come on. Now it's doing something. Hopefully it should print some shapes. Oh. Oh. Ah, it's not happy because I've not installed NumPy in this. Let's just do that. And of course, I should probably, as I'm installing things, a good way to make sure that I'm trying to be a bit reproducible about my software is keep adding to this requirements file. And I can see this is currently installing 1.26.3. So let me just add that. Hopefully it's happier now. Cool. Yes. Okay. So first error. I created some list up here, and those lists probably contain tensors. Yes. Now I need to I have a 10 list of 10 tensors, and I need to convert that into a single tensor with all my data. And I can use torch-cat train data. And I want to concatenate along the first dimension, which is the batch dimension. And train, yeah, we also want that for train labels. Cool. So hopefully this should, oh. Cool. So now we at least got to, let's see. This seems correct. We have 25,000 images of size 2828. We have the same amount of labels, and the test set is a bit smaller. One thing I can already see as a problem is that my image, so when I want to do a 2D convolutions, I need a channel dimension, and currently I don't have one in my data. So I need my train data is train data, and I want to unsqueeze, which is basically just adding a one dimension on the first location. And we also want to unsqueeze this, so we can just reprint this. Cool. Let's see. This data to oh. Cool. Okay, so now we have the one channel dimension for each of the two, the train data and the test data. And it's complete. It's something, it's called data. Isn't it called data loader? Torch utils data with big L. Cool. Yeah, that's why you don't trust
With these.
oh, like that. Cool. Okay. And let's just do a single forward pass to make sure that what we want in the end is 10 probabilities per image, right? So one for each of the possible classes it can be assigned. So let's just take a test data point. let's just do it like that. Let's make sure we need to transfer that to device. And let's just look at the shape of this. Yes, so we input one image and we get an output vector of 10. So this seems correct to me. Okay, for training. So for epoch in range num epochs, we define that. For batch in train data loader, we say x comma y. So our each batch consists of an image or a tensor of images and a tensor of labels. So let's unpack that. Let's start by transferring to our device both things. And now we're running into, we don't have an optimizer. So let's define one of those. Optimizer, torch, optim. Yeah, let's pick Atom. That seems like a good choice. Cool. And yeah, we also need a loss function. That's probably a good idea. We need to remember to zero our optimizer in the beginning. We are calculating, we are getting our prediction from our model. Then we need to calculate our loss with our loss function between what we predicted and what our target is. We need to backward that loss through our neural network. And we need to optimize afterwards during the actual gradient stepping. So this should work. And let's just print something. Let's see if this runs. Yeah, and the loss goes down. So something is working. But the end goal was to produce an accuracy score, if I remember correctly. So let's set up a simple inference loop. So let's start by putting our model in evaluation mode. For this particular architecture, it doesn't really have any influence because we don't have dropout layers and so on. But let's do it for the... And we had a test data loader. Again, we are unpacking stuff. We are transferring to device. We are getting our prediction. And I think what I want to do is just for now, what do I want to do? Yeah, okay, we can also do that. So a good idea is to, if you want to speed up things in the inference part a little bit, you can use this decorator called nograd, which basically, it turns off this computational graph I talked about yesterday. So that doesn't get captured in the background. Of course, that means you cannot backpropagate when you're using nograd, but that's not the point here to do. So we're doing that. I just want to capture the predictions. So test crits. And let's just do, I also want to capture the labels. I already have those. Let's just do it here. So test crits. I want to append not ipred. I want to probably get like what is the highest probability class, or which class did you assign highest probability to? And let's just also append the y, CPU, make sure everything else is on CPU. Cool. And now this is a list again, as in the beginning. So I need to also do some concatenation. And at this point, I probably want to, now let's just do the accuracy calculation manually. So accuracy, that is the number of test predictions that are equal to the test labels. So this will then be a Boolean vector. And let's just convert that to a float. So we get a vector of ones and zeros. And then if we take the mean, we should get the accuracy. And let's then print that. And let's see. I'm missing. Yeah. It seems overall it's learning something, and we successfully got to the accuracy we wanted. The actual task was to format this as in a certain way, if I remember from the exercise. So let's just try to also do that. So all this part that should go into the data script. And let's say that this instead, it returns these torch tills data, the tensor data set. But let's just try to make this a bit more readable. And like that. So it returns one structure that contains the tensor data for the train data and one for the test data. The model, that should be pretty simple. That's just this guy. Yes, and then in our main script, so I need to make sure I also have Shake installed. So train, we got the learning rate. Let's just also add an option to control the batch size. So click is a easy way to write command line interfaces. So what the goal here is, so I start by defining that I want a CLI, a command line interface. I'm saying that command line interface have two functions that I can call. So I can call main train and I can call main evaluate. And in this case, like what I'm saying here is that my train option has my train function has two options. It's the learning rate and batch size I can provide. It has some default values, and the same can be done for the evaluate. Let's also print the batch size. Cool. My also model. Let's do a bit of renaming. So my model. So import that from there. We have the data, so we don't need, it's already initialized the model, but we need to do the, we need the device again. Like that. We got the model to device. We load the train set, and then we could define the train data loader in here. That's fine. Then let's grab our optimizer loss, that part. So we also need an option for yes, number of epochs, thank you. And we know I need some import from tools import canon. And this seems fine now, and the output of this should be save the model. And then hopefully what we could do is Python main train, we have defined a train function, and hopefully we can also do like that. Cannot import name from model. Did I forget to save stuff? Yes. Model reference before assignment. It's this one, like that. Like that. And it's training. And down here. So this part. See. It's just for simplicity, move the device outside so it's available to all functions. What do we need? We need the test data loader. Should this data. This guy. Probably turn shuffle off, not that it matter. Then this should work. Now, after doing this, we have a model checkpoint, which hopefully when we then run Python main py, now we want the evaluate function, and we called it model checkpoint, so that would just be model.pt. Yep. That went well without too many bugs. So I can put these my solution on the Slack channel if you want to, and but else I hope this this give a bit of insights into how I like to code up stuff. Cool, thank you.
Thank you.
I'm stopping the stream now.